All right, so today we are going to talk about basic trigonometric functions. Okay, so we're talking about trigonometry, which is what this whole quarter is going to be about. Now, trigonometry, all that trigonometry is it's just a branch of mathematics where you study triangles and you find relationships between different parts of triangles, you find missing pieces of triangles. So it's just all about triangles and finding angles and finding sides, okay? So we've already actually started kind of looking at this by looking at the Pythagorean theorem, right? The Pythagorean theorem is part of trigonometry because it deals with finding missing sides of right triangles. Okay, so what we're going to start looking at today is just your basic trig ratios. Okay, so the first thing that you need to know is that in a right triangle, the ratio between the sides is always constant, which means the same for any given angle. We can use this ratio to find side and angle measures, okay? So when you divide two side lengths, right, if the angle is the same, then you're always going to get the same ratio, okay? So that's basically what this is saying. For any given angle, so for one particular angle, the ratio between the sides is constant. And you found that when you did that activity yesterday, right? When you look at the ratio for your one angle, you set your one angle, and then as you moved that slider, it changed the side lengths. But when you divided the side lengths, you always came up with the same ratio. Okay, so that is what we're talking about here. That's all that we're saying, is that when the angle's the same, no matter how big the sides end up being, the ratio between them is always the same. Okay, so there are 6 trig ratios that we're going to talk about. You may or may not remember SOHCAHTOA from a previous class. We're going to talk about what that is. Okay, but the first and most important thing is that you need to make sure you pay attention to what is the opposite and what is the adjacent side based on your indicated angle. Okay, so when we talk about a right triangle, so here's my right angle, right? And then this guy over here, that's also going to be the right angle. Okay, so if we are talking about this angle right here, okay, so if this is our indicated angle that we're talking about, so we're just picking this one as the one that we're going to talk about. Okay, well, from this angle, okay, the opposite side is going to be the one over here. It goes across the triangle. This side doesn't touch the angle at all. The adjacent side, well, there's 2 sides that are technically adjacent, but this one opposite the right triangle, or the right angle, excuse me, that's always your hypotenuse, right? So that's already got a fancy name, and it's always just the hypotenuse. This side over here is going to be the adjacent side. So it's the side that touches the angle you're talking about, but isn't the hypotenuse. Okay, now this triangle over here is exactly the same. If we looked at this exact same triangle, but now we said that we were going to make this our indicated angle, so we're going to talk about from this angle, well, that changes things. This will still be your hypotenuse, okay? That still stays the same because it's still opposite the right angle. But now this side over here is going to be the opposite side because that's the side across from the angle that doesn't touch the angle at all. And now this side down here is going to be the adjacent one. Okay, so even though it's the exact same triangle, which side is opposite and which side is adjacent changes depending on which angle you're talking about. Okay, the hypotenuse will always be the hypotenuse, but opposite and adjacent are relevant to what angle you're talking about. Okay, so that is really, really important. Okay, once you've established that, your trig ratios, all that these are, is it's just telling you what sides are you dividing. So if I'm looking at this angle, am I dividing the opposite side by the adjacent side? So am I doing this side divided by this side? Or am I doing it the other way, where it's this one divided by this one? Or am I dividing this side by that side? Or am I dividing this side by that side? Or this side by that side? Or this side by that side, right? There's lots of different ways that you can divide these 3 sides. And that's what these guys are down here. It's just all the different ways that you can divide those sides. Okay, so the first one that we have is the sine. Okay, so the sine of an angle, okay, to calculate the sine, you just find the opposite over the hypotenuse. So the sine of the angle, which we abbreviate, it looks like sin, but you don't say sin, you say sine. Okay, and I'm going to use this symbol right here, theta. So it looks like a 0 with a belt on. That's the symbol we use for angles a lot of times. So like this would be my theta, and this would be my theta. Okay, so the sine of your angle is always the opposite over the hypotenuse. Okay, and if you remember SOHCAHTOA, that's what this first part is. Sine is opposite over hypotenuse. SOH, sine opposite hypotenuse. So SOHCAHTOA is just a way for you to remember which one is which. You just kind of remember this one word and it helps you remember which ones go where. Okay, so that's our first one, sine. So you pronounce it sine even though it looks like sin. Okay, the next one that we have is the cosine, which we abbreviate COS. So the cosine of my angle, and that is when you divide the adjacent side by the hypotenuse. Okay, so from this angle, it would be this side divided by that side. Okay, cosine adjacent hypotenuse, that's where the CAH comes from. So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Okay, and then our last one, tangent, which we abbreviate tan. So the tangent of theta is always the opposite over the adjacent. Okay, so opposite over the adjacent. So tangent, opposite, adjacent, TOA. Tangent is opposite over adjacent. So that's what this SOHCAHTOA is used for. So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. So it's just one word to help you remember those three. Okay. All right, so those are the three main ones that you're going to see the most. Then there are these guys, cosecant, secant, and cotangent. And they are all related to the functions that are above them. Okay, so they're related to sine, cosine, and tangent. So cosecant, we abbreviate CSC. So the cosecant of your angle is just 1 over the sine. Okay, or you can also think of it as the hypotenuse over the opposite. I'm abbreviating here just to give myself a little more room. But all it is, cosecant is just the flip of sine. So it's the same two sides, but the opposite order. Okay. Similarly, secant, which we abbreviate SEC. So secant is 1 over the cosine of the angle. Or you can think of it as the hypotenuse over the adjacent side. Okay, so it's just cosine flipped. Okay, and then the last one, cotangent, we abbreviate that COT. So the cotangent is, as you surely guessed, 1 over the tangent. Okay, or you can think of it as the adjacent over the opposite. Okay, so all that these three are is it's just these three, but flipped upside down. Okay, now one thing that I want you to make sure that you take a note of here, this is confusing for people sometimes, right? Because these two start with S's and these two start with C's. So what happens is a lot of time people will think that sine and secant are flips of each other and cosine and cosecant are flips of each other. Doesn't actually work that way. I don't know why I didn't make it up. Somebody else did, and they made it confusing. So sine and cosecant are opposite. So it's one S word and one C word go together, and one C and one S. Okay, so just kind of keep that in the back of your head that they don't match the way that you'd think they would. They match opposite letters. Okay? All right, so that is what we've established here. So just as a quick reference for you, right? This little chart that we looked at yesterday. Okay, well, when we compared these opposite over adjacent, that's what tangent is. Okay, so all that it is just like how yesterday when you divided, you found these different ratios, right? Well, the opposite over the adjacent is the tangent. So the tangent of a 25-degree angle is 0.466. Okay, the tangent of a 50-degree angle is 1.192. Okay, opposite over hypotenuse, that's sine. Okay, so the sine of a 15-degree angle is 0.259. Or the sine of a 60-degree angle is 0.866. Okay, now these are rounded, but general idea. Okay, and then the last one is the adjacent over the hypotenuse. That's your cosine. So the cosine of a 5-degree angle is 0.996. The cosine of a 40-degree angle is 0.766. Okay, so all that this table is, when you compare these side lengths, all that this is what tangent is, this is what sine is, and this is what cosine is. Okay, so they're not like magic numbers. They're just like anytime you take an angle and you divide two sides, you'll always get this weird decimal. Okay. All right, so let's take a look. We're going to start by just practicing with these. So over the unit, we're going to be doing more and more complex stuff with this. For right now, we're just going to find the trig ratios of this triangle, okay? So let's take a look and we'll just go through one at a time. So looking at this triangle, in order to find all of these trig ratios, I need to know all three sides, right? And so far, I don't know what this side is. So the first thing that we're going to have to do is calculate that side length. Okay, so step one, okay, is we have to find the missing side. If they'd given us all three, we'd be all set, but they didn't, so we're gonna have to do an extra work. Okay, and I can do that using my Pythagorean theorem, right? This is a right angle here. So this guy is my C, that's my hypotenuse. These guys could be A or B, doesn't matter which one's which. So I'm gonna say 5 squared plus 12 squared equals C squared. So that's 25. That's 144. When I add those together, that's 169. And the square root of 169 is 13. So we figured out that this side length over here is 13. So that's our first step. Great. Okay, so now that we've established that, now we can find our trig ratios pretty easily. So this is my angle down here, right? So the first thing I'm going to do is I'm just going to label what all three sides are. If this is my angle, this side over here has to be the opposite side. This side is touching, right? This side over here is my adjacent side. And this guy is always my hypotenuse because it's opposite the right angle. Okay, so I strongly recommend that you start by just labeling which side is which. And then from there, you can just pull out your little formulas, right? So sine SOHCAHTOA, right? Sine is opposite over hypotenuse. So the sine is the opposite over the hypotenuse. So it's 5 over 13. Okay, cosine. So the cosine of my angle, SOHCAHTOA, C-A-H. So cosine is adjacent over hypotenuse. So it's 12 over 13. Okay, and then tangent, SOHCAHTOA, right? TOA, T-O-A. So tangent is opposite over adjacent. So that's 5 over 12. Okay, and then once you have those three, the next three are really easy. So cosecant, remember the C and the S go together, right? So cosecant is just the flip of sine. So that is going to be 13 over 5. Okay, secant is the flip of cosine. So it's going to be 13 over 12. And cotangent is the flip of tangent. That's going to be 12 over 5. And those are your 6 trig ratios of this particular angle. Okay, now quick note, if we had looked at this angle instead, these would all be wrong. Okay, so if we had looked at this angle instead, these wouldn't be in the right spots. I mean, we'd have the same ratios, but they wouldn't be in this, like sine wouldn't be 5 over 13. If this was the angle we were talking about, sine would be 12 over 13 because it's opposite, right? So the opposite side would have been 12 if we were talking about this angle. So which angle you go from is really important. All right, and then last example here. So in a right triangle, theta is an acute angle. So all that means is that an acute angle, that's an angle that's less than 90 degrees. So when they tell you that theta is an acute angle, all that's telling you is that it's not the 90-degree angle. It's got to be one of the other two, right? Because if you have a 90-degree angle, you can't have an obtuse angle, right? Because if that's 90 degrees, you can't have another one that's 90 degrees because then you'd have more than 180 degrees, right? So it's just saying here it's not the right angle. And then it tells you that the sine is 4 over 9. Okay, and then we're going to find cosine and tangent. So the first thing I'm going to do here is I'm going to draw a picture. So I'm going to make myself a right triangle here. Okay, so we've got an acute angle and the sine of it is 4 over 7. So I'm just going to pick one of these two angles. I'm going to go with this one just because it doesn't really matter. I'm going to pick one of those and call that theta. Okay, and then the piece of information I have is that the sine of theta is 4 over 7. And sine, SOH, right? SOH, this is the opposite, and this is the hypotenuse. So that tells me that from here, this side has to be 4, and this side has to be 7, because this is the side that's opposite the right angle. This is my hypotenuse. I'm sorry, this one's opposite the angle theta that we're talking about. This one's the opposite the right angle. Okay, and then this side is the adjacent side. Okay, so we want to find cosine and tangent. I can't do that without knowing the adjacent side. So just like in the last problem, what we're going to have to do next is we're going to find the missing side. So the first thing I did was I drew my picture. Now I'm going to find the missing side. So this was step 2. So step 1 was draw a picture. Okay, step 2, we're going to find the missing side. So this I know has to be C. These guys could be either A or B, it doesn't matter. So 4 squared plus my unknown side squared equals 7 squared. So that's 16. That's 49. 49 minus 16 is 33. So then x is going to be the square root of 33. You do want to double check if that simplifies at all, that radical. But I know it doesn't, because the only thing that 3 breaks down, or 33 breaks down into, is 3 times 11. And that's not prime, or I'm sorry, 3 is prime, but it doesn't get you anywhere because there's no pairs. Okay, and neither one of those is a perfect square. So it doesn't simplify. All right, so now we know that this is the square root of 33. Okay, and now that we've done that, I need to find cosine and tangent, right? So the cosine of my angle, SOH, right? CAH. Cosine is opposite over adjacent. So my CAH. Wow, that was silly of me. Adjacent over hypotenuse, right? A for adjacent, not A for opposite. That doesn't make sense. So cosine adjacent over hypotenuse. So that's going to be square root of 33 over 7. Okay, and then tangent, TOA, right? TOA. Tangent is opposite over adjacent. So that's going to be 4 over the square root of 33. Okay, technically you're not supposed to leave radicals in the denominator fractions, but I'm not going to worry about that for now. At the time being, you can leave it in the denominator and we'll call that good. Okay, so that is my answer to my 2 problems. All right, so the big takeaway here, right, is just that we're talking about what is trigonometry. It's finding the different parts of angles, okay? And we use these different trigonometric ratios, trig ratios, sine, cosine, tangent primarily, and then less used but still important, these 3. Okay, so all these is it's just saying that anytime you have one angle, the ratio between any 2 given sides is always the same. We found them when we looked at some of these angles, right? We divided them out and then we noticed, oh, look, that's what these ratios end up being, okay? So that's what we're starting to look at, is we're looking at, okay, just for right now, we're just looking at how can we look at a right triangle and figure out this number right here. Okay, so when I look at these, I can look at it and say, okay, like say for this triangle right here, we said the sine was 5 over 13. Well, what does that tell me? Well, 5 divided by 13 is about 0.38. Okay, so we said the sine, which was this column, right? Opposite over hypotenuse, is about 0.385. So if I kind of look through here, I don't have that number exactly, but here's 0.34 and there's 0.42. So this angle that we're looking at has to be somewhere between 20 and 25 degrees. How do I know that? Well, because the sine of it falls between those 2 numbers. Okay, so that's what we're going to end up using this stuff for, is you use the information you have about your triangle to figure out, well, what's the sine, what's the cosine, what's the tangent? And once you know that, you can then look at it and say, oh, okay, well, then I know the angle must be this. Okay, so that's kind of our end game here. And the nice thing is that it doesn't matter which of these trig ratios you use. Cosine is 12 over 13, right? 12 over 13 is about 0.923. Well, if I look at my cosine column, 0.923 would be between those two numbers, right? Still between 20 and 25. Okay, and our tangent we said was 5 over 12. Well, 5 over 12 is about 0.417-ish, right? Well, if I look at my tangent column, 0.41 would be between these two numbers, between 20 and 25. So no matter which one of those three ratios I used, they all pointed me, oh, it's between 20 and 25 degrees. Okay, and that's what we're using trig for. That's why this is such an important area of mathematics.